to today's lesson. Today we are on lesson 1-2. Our objective for today is to apply proof by deduction. Our language objective is to explain the steps we use to prove using proof by deduction. So let's take a look at today's do now. Let's take a look at today's do now. So for today, I want us to pick a number, x, in the given interval. So x can be any number from 1 to 10, including 1 and 10. Pick any number whatsoever, write it down on your paper. Now, I want you to multiply that value by 2. The result that you get, you're going to add 6. Now, your new result, you're going to divide that by 2. And finally, you're going to subtract the original number. So what number do you have? I'm going to write the number on my paper. So let's look at today's thinking. It says, why are proofs important? A mathematical proof is a series of logical steps that show one side of a mathematical statement is equivalent to the other side for all values of the variable. We use proofs in mathematics to show that the mathematics we use every day is correct, logical, and sound. So the proof that we are going to be working with is a deductive proof. To prove a mathematical statement, you, 1, can show that the left-hand side is equal to the right-hand side. 2, undergo general algebraic processes. Very important. You cannot move terms from one side to the other. And notation. When we show an identity or that a statement is true, we use this. Looks like an equal sign, but just with 3 lines. So let's try these. Example number 1. Simple deductive proofs. So use a deductive proof to show that the statement is true. So what I want to do is I want to show that the left-hand side is equal to the right-hand side. That's my goal. So what I'm going to be working with is the left-hand side. And I'm going to use some math processes along the way. I know that if we need to add fractions together, we need to have a common denominator. So in this case, I want to change that denominator 4 to have a denominator of 12. And how am I going to do that? By multiplying 3 on top, 3 on bottom. I am going to keep the left-hand side exactly as it is, 1/3. So I'm dropping that down. Now that I have the common denominator, I'm just going to add the numerator, and I have a 4 over 12, and that's equal to the right-hand side. And what is 4 divided by 12? I'm going to divide both top and bottom by 4. Which makes 1/3 equal 1/3. And that's my proof right there. Let's try number 2. For number 2, I have been given very similar to what I have here, but this time I am going to work with the right-hand side. So I'm going to drop down the left. And just like before, I want to have a common denominator. Multiply 2 on top, 2 on bottom. I'm going to combine numerator. And at this point, since I have this right-hand side all simplified, I am going to now take a look at the left-hand side. And I'm going to simplify that. So I have proven that the left-hand side is equal to the right-hand side, or the right-hand side is equal to the left-hand side. For example 2, what we want to do is look back at that do now question and perform a deductive proof to the do now problem. So I gave you a problem in which you had to do multiple steps and you got to a value. And I told you that that value was 3. So I'm going to do a deductive proof on that. So I'm going to start off by saying let x equal any integer. So the first thing that we did was we started off with a value of x. Then I told you guys to take your number and multiply by 2. So what's gonna happen there? We're going to do 2 times our x. After that, I said add 6. So I'm going to take my 2x and add 6. Then I said divide by 2. So if I divide everything by 2, I would get x plus 3. And last thing I said is subtract the original number. And if I subtract x, I would get 3. And that is how I knew your answer would be 3. Let's look at example number 3. Algebraic equations. So we are going to prove that the left-hand side is equal to the right-hand side. And if you notice here, we have our notation. So what I'm going to start off doing is apply distribution. I'm going to take the same route I would if I was solving an equation. So I am going to combine my like terms. And I am stopping here because I showed that both sides are the same. Okay, so let's try number 2. Number 2, very similar to the first one, just a little more algebraic involved. So what we are going to start off doing is that binomial, and we're going to slowly start simplifying it. Okay, so at this point, I am not able to prove that both sides are equivalent. So I am going to cross that out. Number 3, I am going to work with this piece here on the right, and I'm going to simplify, combine my terms, do my mathematics on the highlighted piece. All right, at this point, I'm almost done. I'm going to cancel that out, and I am left with the exact same thing, which means I did it. I was able to prove that. So most often we're able to prove something true, but once in a while, just like number 2, it is not possible. So keep learning, keep growing, and I will see you in our next video.